although it is true is the reverse, but I think a better question, a better way to learn R formula is to really look at what it does. Yeah, let's look at what it does. Okay, because if I say it's the reverse, it is true, but we seldom use it that way. Yeah, it's like saying that washing hands is quite refreshing, but that's not the reason why we do it most of the time. Yeah, it's refreshing, but what we really want to do when we wash our hands is to be hygienic, right? To kill off the bacteria and germs before we eat. That is the real purpose of why we use the R formula. Okay, so the reverse, the R formula is the reverse of the addition formula. But like I said last week, I'm not sure if you remember, last week we talked about this. We had a quick look at decimals, remember? Where we played around with two different trigonometric functions. Yeah. So my first function is sine A of x. My second function is cosine B of x. Yeah. And I only interest myself in sine and cosine. I'm not going to deal with tangent, secant, cosecant, or cotangent. Just sine and cosine. Just sine and cosine. Okay. So, and then the thing we talked about last week was what? Do you remember what we said? What was the thing that we discovered from playing around with, say, A and B? When A and B are the same, something funny happens, right? And that is, we actually get a graph that is, the same frequency, the same period as our original, individual graphs, either the cosine B of x or sine A of x. It's actually the same period. Can you see? It's the same period, but it's been shifted off a little bit. Yeah? Can you see? Like the peaks and the valleys are not totally aligned between the black and the red. Yeah? So it shifts off a little bit. Also, another thing that we realize is that the maximum height also changes. Right? The amplitude also changes. Okay? And all this only happens when, right, the angle is the same. Yeah? So this is how I look at it. Yeah? Sometimes we have questions where you have things like a problem. Okay, let me go back to the iPad. For example, if I want to work out the size of a playground, for example. Okay? Maybe it turns out that this length over here is 5 cosine theta. This is like 7, and maybe this is 8, this is 4, and this is 2 sine theta. Okay, then I want you to find out what is the maximum perimeter of this shape. What is the maximum perimeter of this shape? Then it's a bit difficult, right? Because you can add 8, 4, and 7, no problem. That's 19, plus 5 cosine theta, plus 2 sine theta. Then the question comes, what is the maximum value of this? Correct? What is the maximum value of this? Say if I give you back to decimals, 5 cosine theta, and okay, let's change it back to theta equals to 1. Okay, then I have 5 cosine theta and 2 sine theta. Yes, so if I show you these two graphs, this is 5 cosine theta, this is 2 sine theta. Can you tell me what is the maximum value if I have to add these two together? It is quite impossible to determine, right, what is the maximum value. Is it when, the black graph is maximum and then the blue graph is 0? Is that the maximum? Or is it when they intersect? Or is it somewhere in between? Like maybe like just over here and then here? There's no way of telling what is the maximum value. Correct? So we have this problem on our hands. Let's go back. What is the max? Max or minimum? Okay, so if they are both theta, oh, that's a bad color. Right. They are both theta, and that means I can combine them into a single graph. Yes? So let's go back into decimals. Okay, let's take 5 cosine plus 2 sine. What do I copy? Control C. plus this. Okay, then when you add them together, you realize, okay, now I get a totally different graph. Can you see? The maximum no longer happens at x equals to 0. It's shifted a bit off. Can you see? And the maximum height, now you can get the maximum height. It is 5.385. 5.385. And that happens when x equals to 0.381. Theta equals to 0.381 radians. Okay, and so this can help you in your design. If I want to maximize the parameter, then I need to make sure that my angle, theta, is 0.381 radians. Then my maximum parameter will be, let's go back to the iPad now. So the max is 5.385. This thing, theta equals to 0.381. This thing becomes 5.381. Then my maximum parameter is 24.381, something like that. Okay, that is the power of R formula. Does that make sense? I think it's better than saying that it's the reverse of the addition formula, because this is really what are the questions you'll be seeing in your exam papers. Yeah, so this is R formula. Then next, you might be interested in like, hey, wow, okay, this is nice, but how then do I know, how does this thing turn into plus 2 sine theta? Then I know that roughly this equation is true. 5.381, either a sine or cosine something something, theta plus something something, or minus something something, some angle. Correct? Because if you go back and look at the graph, okay, let's go back and see here. You know the amplitude is 5.385. Why do I keep writing 5.381? It's 5.385, sorry. Okay, you know the amplitude is 5.385. And it looks kind of like a cosine graph, just shifted a bit to the right. Correct? Because the cosine graph starts at x equals to 0, you have the maximum here, somewhere around here, right? Right. So if I type in the graph, say 5.385 cosine x plus a certain number, a. I shouldn't use a because I already used a. So let's use a new constant c. Okay, and then if I slide c, right, then I should be able to get this when c equals to negative 0.4. Can you see? The two graphs are roughly the same. That means, let's go back to the iPad. Sorry, they do a bit of switching back and forth. That means this thing, right? Okay, by trial and error, is equals to 5.385 cosine theta minus 0.4. But the question should be like, why? Why is it equals to that? Correct? So now let's look at how we can, how can we turn the reverse, right? Like, if I give you this, you know how to expand. Because this is just addition formula. But how do we go from here backwards to here? That is what your teacher is trying to say. It's the reverse of the addition formula. But I think going that way is not really that interesting. Yeah? We want to know why is this true? How come this one can become like that? Do you know how to do it?